In our final tutorial, we will solve nonlinear systems using a substitution method. Let's flip over to example 7 in our notes. We are solving systems now by substitution. To solve by substitution, we want one of our variables to be solved for. I see in our first equation here that we have y equals this stuff. That means that once I have y equals to something or x equals to something, I can circle that expression and plug it into the other equation in place of that same variable. So since y equals this trinomial, this y can be replaced by this trinomial. And then I'll write this new equation. The y has changed its name to x squared minus x minus 6. And then I have the rest of my equation, minus 2x equal sign and negative 2. So now we have an equation that only has one variable in it. We should be able to solve this. This is a quadratic equation because we have this x squared term. And quadratic equations, we should always set equal to 0 first. So I'm going to add my 2, and I'm going to put it underneath its like term, which is over here. And at the same time, I'm going to get my like terms together. I see a negative 1x and a negative 2x. So let's see what I've got here. I've got my x squared. Nothing's changing that. Negative x minus 2x is negative 3x. And I had negative 6, but since I added 2, I've got negative 4. And of course, over here, they canceled away. I want to see my 0. Now I can solve this quadratic either by graphing or by factoring or by completing the square or by quadratic formula. I'm going to choose to factor. At least I'm going to try to factor first. This is a simple trinomial because a is 1, so only x times x is the option for the front. It's 1 times 4 or 2 times 2 in the back. Let's see what happens to our factors. Please do not forget that it's still equal to 0. So the x's go in the front, that's the only option there. I do know that I'm trying to get a negative 3, so the 1 and the 4 make sense. And I do know that my signs alternate. So one's positive, one's negative, and since I need a negative 3, I'll put the negative with the 4 and the positive with the 1, because 1 minus 4 becomes negative 3. So I know I factored that correctly, and you can watch the tutorial on factoring if you need a reminder for that. So this factor will give me that x is equal to negative 1. This factor will give me that x is equal to positive 4. So it looks like we have two answers to this system. One of them will have an x coordinate of negative 1. I'll go back and find the y coordinate. The other one has an x coordinate of 4, and I'll go back and find that y coordinate. So we're about halfway there. Once I know what the x value is, all I need to do is plug those numbers back into the original circle and find the y coordinate. So y is equal to x squared minus x minus 6. Let's start with the negative 1. If x is negative 1, then we have negative 1 squared minus negative 1 minus 6. And let's see what this number is. Negative 1 squared is 1, minus negative 1 makes plus 1, minus 6. So this is 2 minus 6, which is negative 4. So when x is negative 1, y is negative 4. And that's one of our solutions. There's my ordered pair. Let's now try the 4. We'll plug the 4 into the same thing and get a different y. Well, most likely a different y. So we've got 4 squared minus 4 minus 6. And that's going to be 16, take away 4, take away 6. Well, if I have 16 things and I take 4 of them away and then I take 6 of them away, I'd be left with 6. So when 4 is the x, 6 is the y. And I solved this system. There were 2 solutions. So I substituted, I combined my like terms and set the equation equal to 0 since it was quadratic. I solved by factoring, found 2 x coordinates, plugged those numbers in for my x, and found the new y's. And wrote my answers, of course, as ordered pairs. Another example, example 8. X squared plus y squared equals 25. And in the bottom, I've got y equals x plus 1. Well, that's nice. Since y is solved for, I'm going to take this x plus 1 and I'm going to put it right into the other equation in place of that y. So I'm going to have x squared plus the y is going to change to x plus 1. So that x plus 1 is going to be squared. Instead of y squared, it's x plus 1 squared equals to 25. The next thing I need to take care of is this quantity that's being squared. So I'm going to leave my x squared alone. This x plus 1 squared means that I have two factors of x plus 1. I'm going to write them side by side so that I can see that I'm going to be foiling them. I'm going to be double distributing them. However you want to do this, there are four products: x times 1, 1 times x, 1 times 1. X times x gives me x squared. My outer terms, 1x. My inner terms, another 1x, so that's 2x. And my 1 times 1 gives me a 1, and equal to 25 still. I now still know that this is quadratic because I see x squareds. So I'm going to set this equal to 0, like all quadratics should be set equal to 0 before I start solving. And let's get my like terms together. I have 2x squareds. I've got my 2x's, and this is negative 24. All equal to 0, and that's what I wanted. I wanted my 0. And actually there's one more thing. Each of these coefficients is even. I could divide everything by 2. I don't really need the 2. The numbers do not have to be this big. So I can write this as 1x squared plus 1x minus 12 equal to 0. That makes it a little bit easier. The smaller numbers. I'm going to factor this as well. X times x, 12, 1 times 12, 2 times 6, 3 times 4. So let's see what we've got. I know the x's are going to be in the front. That's the only option for the front. It's still equal to 0. I'm going to choose the 3 and the 4 because that's what's ultimately going to make a 1. So I'll put 3 and a 4. I know my signs alternate and it needs to be a positive 1, so the bigger number will be positive, the smaller number will be negative. So now I've got that x could be equal to to positive 3, or x could be equal to negative 4. All right, running out of room here, but here we go. We've got one answer, at least the x coordinate of that answer. I'll find the y coordinate. And the other answer has an x coordinate of negative 4, and I'll come back and find the y coordinate. So now that I have my x values, I'm going to plug them right back in to the original thing that I circled. Well, in this case, I put a rectangle around it. And let's see what we have. I know that y is equal to x plus 1. So let's start by plugging in the first x, the 3. So this becomes 3 plus 1. Well, that's not too bad. That's just equal to 4. So when I plug in a 3, I get out a 4. That's one of my answers. Now I'll plug in a negative 4. Right back in here, I know that y is equal to whatever x is plus 1. So now it's negative 4 plus 1, which is pretty easy. That's just negative 3. So when I plug in a negative 4, I get out a negative 3. And those are my two ordered pairs for this system. And there's two good examples of substitution. This example is a little bit different, a little bit easier, I guess. So we're given a system, here it is. It says, what are the x values for the solutions to the given system? So we're actually not going all the way to our final answers. We're really just looking for the x values. So that's not too bad. I do see that y equals this and that y equals this. So I could really substitute for either one. I'm just going to take the first one, this x squared minus 16, and I'm going to substitute it into the second equation in place of that y. So the x squared minus 16 will take place of that y, and then equals the rest of this, negative x squared, negative 4x, positive 14. I see that this equation, again, is quadratic, so I'm going to set everything equal to 0, and we'll figure out a way to solve that. I like my quadratic term to stay positive, and this one is nice and positive, so if I add the other one to it, it's going to remain positive. I like that. So I'm going to bring everything to the left side. So I'm going to add my x squared. I'm going to add 4x. There's really not a place for that, so I'll just try to squeeze that in the middle since that's where it would go. And I'll subtract 14. try to put that underneath its like term. So that's gone, that's gone, that's gone. I've done all the opposites. X squared plus x squared gives me 2x squared. The 4x is just going to sit there next since there's nothing to add to it. And negative 16, take away 14 more would be negative 30. And there's my 0 since everything else canceled away, and I need to see my 0. So now I'd like to solve by factoring, but before I do that, I again see that I've got even numbers here, so I could divide everything by 2. I could divide each one by 2 individually, or just put a big division bar and divide by 2, as long as I remember that I'm dividing all 4 of these terms. 2x squared divided by 2 would become 1x squared. 4x divided by 2 is 2x. Negative 30 divided by 2 is negative 15. And 0 divided by 2 is still 0. That's a little bit more manageable, and let's factor that. Another simple one. A is equal to 1. So x times x, I've got 1 times 15, but it's probably going to be the 3 and the 5. Yep, that makes 2. So let's go ahead and put my binomials here. Don't forget that it's still equal to 0. The x's are in the front of the parentheses. I'm going to choose the 3 and the 5. Now let's talk about my signs. Again, they're alternating. To get a negative 15, I must be multiplying a positive times a negative, and since it needs to be a positive 2, the positive will go with the 5, the negative with the 3. Do a quick mental check. Negative 3x is the inside, positive 5x is the outside, negative 3 and plus 5 make positive 2. So I know that I'm correct. And let's see, my factor of x minus 3 would correspond to an x coordinate of 3. And my factor of x plus 5 would correspond to a 0 or an x coordinate of negative 5. And actually, we're finished. Remember, we're just looking for the x values of the solutions, so we found them. We do not need to plug those back in to find the y values. It just said to find the x values. So we're finished. Ah! All right. So let's flip over and look at our final example. A little bit different here. I'm giving you a possible solution. This ordered pair 2, 4. I want to know, is this a solution to the system of equations? And here's my system. I have 2 equations. I have this quadratic and I have this circle. You graphed circles in geometry, and we'll graph them later in advanced algebra. If this is going to be a solution to the system, then that must mean that it works in both of these equations. Well, so let's see. Let's see if it works in this first one. I have that y is equal to x squared. So the y coordinate of my possible solution is 4, and I want to see, is that equal to 2 squared? My x coordinate would be 2, and that would be 2 squared. I put a little question mark above my equal when I'm testing to see if something is true. This is pretty easy to see that 4 equals 4. That is true. Does that mean that this is a solution to the system? No. That means that this is a solution to this first equation. It means that it is a point that is on this equation. That's not a solution to the system. Remember, the system is where these 2 equations intersect. So this, to be a solution, must also work in the second equation. So my second equation is x squared plus y minus 2 squared equals 4. Let's plug my x and my y in this equation as well. So my x squared becomes 2 squared. My y minus 2 becomes 4 minus 2, quantity squared, equals 4. I'm going to put a little question mark because I don't know if this is true or not. 2 squared, of course, is 4. 4 minus 2 becomes 2 squared. And this is 4 plus 2 squared is 4 equals to 4. I'm getting 8 is equal to 4. Well, that obviously is just not true. So since this ordered pair does not work in this second equation, it is not a solution. It must work in all of the equations. Just because it works in one of the equations, that's not enough. It needs to work in all of the equations to be a solution to the system. Thanks for watching this. This is the algebraic tutorial. We solved things by substitution, and we'll practice this more in class when I see you then. Bye-bye.